As we start Chapter 2, we'll be moving into solving linear equations. And these, in a sense, linear means they're just to the first power. All right, number 1, solve the linear equation. Express solution as an integer. So I'll model this one for you. 13 y minus 14. Now, often we don't want to destroy the original equation, so you should write it out again. Now, what we want to do is get the y's on one side by themselves, and then the numbers on the other side. So what do we have to add to a negative 14 to make it 0? Well, you might say a positive 14. But if you do it to this side, you must do it to that side also. So here we end up with a y left by itself because this is a 0, and this becomes 27. So our answer here is 27. Okay, now let's do this next one. Start it out together. So we have, well, before we do it, a good idea would be to inspect. Notice we have like terms here. So 9z minus 8z would be a 1z. If it's a 1z, we don't write the 1. And then we have a plus 4 equals a negative 18. All right, take a moment. What would you do to this side to isolate the variable? In this case, a letter z. Well, you're going to subtract 4 from this side, subtract 4 from that side, and you get z equals a negative 22. So some easy ones to start. Now I've written these out, but we want a technique that when we see an equation with fractions, we want to be able to get rid of those fractions. So the clue is, what would our least common denominator be between a 3 and a 4? And if you said 12, that is correct. So the protocol will be something like this. You've written this in your booklet, maybe a little smaller than this. You've put brackets around the whole thing. And now out here you're going to write the least common denominator, which is 12. So what's next? Well, you're going to multiply each term by 12. And this is a term, this is a term, this is a term. So here, this just becomes 12z. But now, when you multiply 12 times this term, you can cancel out the 3. So 3 goes into 3 once. 3 goes into 12 4 times. 4 times 4 now will give you a 16. Now 4 will go into 12 3 times. 3 times 5 is 15. So you've made this equation much easier by getting rid of the fractions, by multiplying through by the lowest common denominator. So what do you do now? Again, you want to isolate the 12z on one side. So to get rid of this 16, I'm going to subtract 16 here. I'm going to subtract 16 there. And I now get 12z equals a negative 1. Now, what do? I want to get z by itself. Well, I'm going to divide 12z by 12. That is the numerical coefficient of z. Do that to both sides. Here they cancel out. become a 1, and z is equal to a negative 1/12. Now, this one's a little different. Now, you could multiply both sides by 6, but when there's just a fraction like this, we're going to use another technique. And that is, what can we multiply any number by? And in this case, it's 7/6, so that eventually it's going to equal a 1. And the answer is you can multiply anything by its reciprocal, and that makes it 1. What is the reciprocal of a number, particularly a fraction? Well, you just flip it over and say 6/7. So multiplying 7/6 by 6/7 gives you a 1. So here, if we multiply this side by 6/7, and what you do to one side, you must do to the other, 6/7. Here, this just becomes a 1, and this is a 1. So you have a 1x equals, now in a sense, this is over 1, so you can't do any canceling here. So this is a negative 36/7. Now, as we move on, again, I've taken the liberty to write this again. You don't want to destroy your original example, and just check that you've copied it correctly. Yes. Now, again, this is an equation with fractions. You want to get rid of the fractions. So our protocol will be put a bracket around the whole thing. And as we look at this, what will be our least common denominator? We have a 2, a 5, and a 3. Well, 5 times 3 is 15, times 2 is 30. Would 30 take care of all our denominators? And the answer is yes. So we're going to multiply everything by 30. So each term, this is one term, one term, one term, one term. So 2 goes into 30 15 times. So 15 times 1 is 15x. 5 goes into 30 6 times. So 6 times a negative 4, a negative 24x. 3 goes into 30 10 times. So 10 times a negative 4 gives me a negative 40. 5 goes into 30 6 times. 6 times 1 gives me a 6. So that's where we are. Now, can we combine like terms? Yes, here this will become a negative 9x. And this is going to become a negative 34. Now, to isolate the x, we have to divide out the numerical coefficient, which is a negative 9. Now, we have to be careful of our signs. So negative divided by a negative gives me a positive x. A negative divided by a negative gives me a positive 34/9. And that's what we put as our answer. So this one was a little challenging. But notice, this technique is super important. When you see an equation with fractions, you're going to multiply each term. Now, in a sense, it's not the same equation, but it is equivalent. You've made it bigger, gotten rid of the fractions. Much easier to work. All right, that'll complete our section 2.1. Let's go on to 2.2.